Hi, my name is Evan Wozniak, and this is my video submission for homework number 5. I'll start with a brief overview of my physical setup. The region I'm monitoring is this section of the room in my apartment that leads to my bedroom door, which is over here on the left. In order to get a good camera angle, I've stacked up several old cereal boxes on top of this rolling cart in my room. Because my laptop doesn't have an outward camera, I've set up my phone to use as a webcam instead. On top of these boxes, right here, is a stand that I'll place my phone on when it's time to run the code, right here. Because I'm using my phone to record this video, you obviously won't see it on the stand right now. This setup isn't very advanced, but it still gives me a consistent and constant view of what I want, which is the most important thing. Now, I'll make a cut so I can discuss my code. Now, I'll discuss my code by walking through my detection pipeline. So I start with these lines of code by setting up my camera and the email that I'll use to send my images. I then proceed to this function here called grab frame, which simply just gets a frame from the camera. And then my other function that I have here is called mask image, and this does a couple of things. First, it sets up the mask array, and then I also define the points that define the area of interest that I'm looking at, and then I fill those points using fill convex poly. I then apply the mask to the image that was passed into the function. I resize the masked image a little smaller to make the comparisons easier. And then I convert the masked and resized image to grayscale. And then finally, I apply a Gaussian blur to that result. And I used a kernel size of 15. This differs from what was used in lecture, and I found this size to be optimal in terms of sensitivity to picking up differences between the first and the second image. I simply determined this value by doing trial and error, and I found that kernel sizes higher or lower than this had a tendency to be less sensitive. Moving on, I kept this counter variable just in case I wanted to do analysis or troubleshooting later. And I move into this while true loop. So the first thing my detection pipeline does is it takes a first image and a second image to compare, and these two images are separated by a time delay of about half a second. This also differs from what was used in the lecture videos. I determined half a second to be the optimal delay between the first and second image, largely using trial and error. I found that half a second was as quick as I could get of a delay before the two images started to show little difference between one another. So I found that anything lower than about a half a second, the two images tended to be pretty similar to one another. So the next step in my pipeline is I mask the images, both 1 and 2, and then I compare the two images. So I set a pixel threshold of 50. This is the same as what was used in lecture. I tried changing it higher or lower. I didn't find much of a difference in terms of performance, so I just kept it the same. Obviously, if I made this too low, then I would be picking up on things that might not necessarily be notable differences. And if it was too high, I might be missing differences. I also set up this variable called detector total, and then an array called detector. So the next step in my pipeline is a pixel by pixel comparison between the first and second image that were masked and grayscaled. So I go pixel by pixel, and I determine that between the first and second image, if there's a difference between an individual pixel that is greater than the threshold, I go ahead and set that corresponding location in the detector array to high, or 255. Next, I sum up all the the entire total of the detector array, so every single element. And then I move into the next step of my pipeline. So I have an if statement here that says if the detector total is greater than 40,000, then that means an object was detected. So in lecture, I believe this value is about 30,000. So I raised the total to 40,000 because I found that values lower than this had a tendency to pick up things like changes in shadows in the room and falsely report them as detected objects. So this was about as low as I could get um, before I would start having that shadow issue. So next, I just get a time string to have a unique name for the new video file. I save the two images locally. And then I go ahead and set up my video writer right here. And I get a timestamp. And I get this timestamp because I go into this while loop that serves as a timing loop. And this allows me to record a video of about 15 seconds. In actuality, sometimes this video ends up being a little shorter, like 13 or 14 seconds, due to some timing inaccuracies or frame rate differences. But anyways, this loop goes through and basically writes frames to a video MP4 file. And then I go ahead and take the two images that I saved and put them into this array of attachments. And I set up a subject line using the time string that I identified earlier. And then finally, this line here will send an email to my TerpMail account containing the first and second image after an object was detected. And then finally, I release the video writer and exit the if statement. And the whole thing will loop again, allowing me to repeat the process. So now I'll go ahead and cut so I can make a live demo of this algorithm in process. All right, so now I'm going to transition into the demo portion of my video. I'll be showcasing the full performance of my detection pipeline. So I will note that you won't be able to see a live camera feed of me as I walk into the area of interest. That's because I'm screen recording right now, and I found that if I try to show the feed and screen record at the same time, I run into a lot of issues. But you'll be able to see me in the video that gets recorded after the fact. So I'll go ahead and start running my code. And we'll see a line down here when the system's ready. Okay, system's ready. So now I'm going to go ahead and take my laptop and walk into the area of interest by my door. And we see that I was detected. So I'll go ahead and wave to the camera so we see it in the video. And I'll walk back out of frame. And we'll see a line here in the console that says the video was saved when it's done being written. So the video is saved and the email is sent. So now I'm going to go ahead and stop the code so we can take a look at the outputs. So I'll start with my email first. Go to my email, see I got a message, smart doorbell recording, timestamped at the current time. Go ahead and open it up. See I got two images. And we see image 1 and image 2. Clear difference. Clearly see me walking into frame with the laptop. Next, go into my local files so we can see the video. And we see here I have an MP4 file titled doorbell, followed by the current timestamp. Now before I click this video, I will note that similar to the live feed issue, because I'm screen recording right now, I have noticed that caused a bit of an issue with the video writing. So this video will probably be a little bit longer than the 15 seconds I said, and it'll probably be a little bit choppier as well. If I wasn't screen recording, that wouldn't be an issue, but because I'm screen recording for the purposes of this video, it is. So go ahead and play the video.
from the beginning. You see me walking into frame, waving, walk back out, just talking the whole time, like the video, and the rest is just the empty space. Go ahead and stop that. So that is my full algorithm's performance. Now I'll go into some recommendations. So for one, a better camera. I was just using my smartphone, which has a pretty good camera, but I'm having to connect over Wi-Fi, and that comes with its own issues that the Wi-Fi is not running very well. So a better camera that's more dedicated to this purpose would probably increase the detection capabilities. Also, a more dedicated hardware setup, as we saw. My camera is just set up on some old cereal boxes and propped up. And while it's consistent, it's not really a good dedicated setup for a doorbell camera that would be in full-time use. Next, software wise, I would want to do more tweaking and testing of parameters to further optimize the algorithm. If I get some better hardware in hand, some of the things like the amount of time I'm taking between pictures and the pixel thresholds and detector thresholds, that might change. I also want to test this algorithm in different settings. I'm just testing it in my bedroom, so the lighting is pretty consistent. I don't have to worry about things like wind blowing trees and things and that getting picked up by the algorithm. So I'd like to test this in different locations and see how that might alter the thresholds. And then finally, I'd like to look into adding the text message and Dropbox functionality that was discussed in the video lectures, but I was unable to do because I didn't have my hands on a Raspberry Pi. So hopefully in the future, if I manage to do that, get my hands on one of those, I can add that functionality as well. But that's all I have for my video. Thank you.